supposed to solve for values of theta between 0 degrees and 90 degrees. If sine of theta is 0, find cosecant of theta. Well, sine and cosecant are reciprocals. So if sine of theta is 0, that's 0 over 1, it makes cosecant of theta 1 over 0, which is undefined. Therefore, cosecant of theta is undefined. Number 2, tangent of theta is 1. Find cotangent of theta. Well, those are reciprocals. If you reciprocate 1, you're going to get 1. Therefore, cotangent of theta is 1. Number 3, tangent of theta is square root of 3 over 2. Find secant of theta. These are not reciprocals. Tangent is y over x. Secant is r over x. So to finish this problem, we have to know what r is. To do that, use the Pythagorean theorem. Put our y as square root of 3 and our x as 2. To figure out what r is, use Pythagorean theorem. Square each leg and add them together, equals the hypotenuse squared. 2 squared is 4, square root of 3 squared is 3, 4 plus 3 is 7, therefore r is plus or minus the square root of 7. This is a radius. Radius is always positive, so it's positive square root of 7. Therefore, secant of theta is r, which is square root of 7, over 2. This should be square root of 7 over 2, not square root of 3 over 2. Number 4, tangent of theta. Tangent's y over x. Trying to find secant, which is r over x. Once again, we don't know what r is, so draw a right triangle in quadrant 1, because the direction said it was in quadrant 1. Figure out what r is, use the Pythagorean theorem. 2 squared is 4, square root of 11 squared is 11. So we're going to get r squared is plus or minus the square root of 15. R is always the radius, which is positive, so it's positive square root of 15. Secant, which is r over x, is going to be square root of 15 over 2. Number 5, a cosine of theta is 2/3, so find cosecant of theta. Cosine is is x over r. Cosecant is r over y. This should be a y right there. I'll fix it in a moment. We need to know what y is to figure this out. So once again, label your triangle with r and x. Trying to figure out what y is with the Pythagorean theorem. 2 squared is 4, 3 squared is 9. It's going to make y squared 5, which makes y plus or minus the square root of 5. We're in quadrant 1, therefore it's positive square root of 5. Change that. Cosecant of theta is r over y. Our y and our r, we got 3 over the square root of 5. Denominator should not have a radical, so multiply the top and bottom by the square root of 5. You get 3 times the square root of 5 over 5. Number 6. Once again, we got y over x because it's tangent. We want to know what r over x is, because that's what secant is. Use Pythagorean theorem, just like we did for the other ones. You're going to find that r is plus or minus square root of 53. It's a radius, so it's positive square root of 53. Therefore, secant of theta is square root of 53 divided by 2. Number 7, y is 1, x is 2. Need to know what r is using the Pythagorean theorem. 2 squared is 4, 1 squared is 1. You're going to get that r is plus or minus square root of 5. This should just say 5, should not say square root there. Therefore, sine is y, which is 1, over r, which is the square root of 5. Rationalize your denominator. You get square root of 5 over 1, over 5, I mean. Number 8, express each value as a function of an angle in quadrant 1. You might find finding a coterminal angle is a good choice. I'm going to subtract 360 degrees from this. That gives me 202 degrees. That falls in quadrant 3. Makes the reference angle 22. In quadrant 3, x and y are both negative and r is positive. Therefore, our answer is cosine of 22 degrees, because 22 is a reference angle, but it's a negative cosine because in quadrant 3, cosine is negative. Number 9, if you find a coterminal angle, you don't have to, but if you choose to, I'm going to add 720 degrees to this. That's 2 revolutions. Gives me negative 72 degrees. This should be a negative, not a positive. That's in quadrant 4. In quadrant 4, x is positive, y is negative, and r is positive. Therefore, our answer is sine of 72 degrees, because 72 is a reference angle, but it's a negative sign, because in quadrant 4, sine is negative. Number 10, I'm going to leave this angle as it is. I'm not going to find a coterminal. Negative 210 degrees, that's clockwise, puts me in quadrant 2. Makes the reference angle 30, because that's 30 is, if you add 180 and 30, you get 210. That's why it's 30. In quadrant 2, x is negative, y is positive, r is always positive. Therefore, it's secant of 30 degrees, but it's negative because we're in quadrant 2, and in quadrant 2, secant and cosine are both negative. Number 11, I'm supposed to simplify this. When I look at my denominator, I see a secant and I see a tangent. I'm going to change those. I'm going to change secant to its reciprocal identity. I'm going to change tangent using its quotient identity. Now, on the bottom of my fraction, I'm subtracting 2 fractions. So I want to get common denominators, which I already have. So I'm going to subtract those. To do so, I'm just going to take 1 minus sine of theta over the original denominator of cosine of theta. This is a complex fraction. To make it non-complex, take the numerator, cosine of theta, and multiply it by the reciprocal of the denominator. It gives me cosine times cosine, which is cosine squared. This is not very simple. I'm supposed to simplify. My numerator, cosine squared of theta, is actually the same thing as 1. I skipped a step there. Shoot. Here's what I skipped. Cosine squared of theta is actually 1 minus sine squared of theta. And then 1 minus sine squared of theta factors into this. It's a difference of 2 squares. The same kind of problem comes up again. I think it's number 14. So if that didn't make sense, I think I did it better in number 14. Let's see here. Number 12, I'm going to change cotangent to cosine over sine. Your sines cancel, and you're just left with cosine of A. 13, I'm going to change everything to terms of sine and cosine. Tangent using the quotient identity, and cosecant using the reciprocal identity. Sines cancel, cosines cancel. We just have 1 times 1 times 1, which is 1. 14 here is just like 11. That step that I skipped, I'm going to rectify it here. Cosine squared of A is 1 minus sine squared of A. If you notice the blue down here at the bottom, that's Pythagorean identity. That numerator then factors. 1 minus sine squared of A is 1 minus sine times 1 plus a sine. It's a difference of 2 squares. You can cancel 1 plus sine of A on the top and the bottom, leaving you with 1 minus sine of A. Number 15, if you factor out the GCF, sine squared, what you have left in parentheses is just 1. Sine squared times 1 is sine squared. Number 16 is the perfect square trinomial, which factors in the cosine squared of alpha plus sine squared of alpha squared Inside parentheses is 1, Pythagorean identity. You square 1, you get 1. Here's how you do perfect square trinomial. Is the first term a perfect square? Is cosine to the fourth a perfect square? Yes, it is. What's its square root? Cosine squared. Second question, is the last term sine to the fourth a perfect square? Yes, it is. Square root, sine squared. Third question, if you take those two answers you got from 1 and 2 and double it, does it give you the same thing as the middle term? Yes, it does. Therefore, this is a perfect square trinomial, and it factors just what you see up here. 17, we're going to change tangent to sine over cosine. Cosines cancel. Sine of x plus sine of x is 2 sine of x. 18, write an expression for each of the following in terms of the given function. Cosine and sine are in the trig identity. If you get cosine squared by itself and then square root both sides, you get that. 19, tangent in terms of cosine. Tangent of theta is sine over cosine. Recall that sine squared plus cosine squared is 1. If you get sine by itself, you get that sine is plus or minus the square root of 1 minus cosine squared. Plug that in for sine. Tangents by itself, the right side is using cosines and numbers. Done.